Yeah, now it's 4 o'clock, last keynote, and she's talking about security, right? All right. So I need a quick check-in with you all. So who knows what S-bombs are? Wow, that's almost 100% amazing. Okay, so you're gonna love this, I hope. But super quick. That's actually missed my title slide. So, my name's Constance. I do have a doctor, but for this, a degree. But for this talk, it's very important that you do not take medical advice from me. Okay, I'm not that kind of a doctor. And the other thing to point out is all the funding agencies and also the many individuals that have supported this initiative so far, so that it's actually possible for me to be independent up here and standing without any logo or sponsoring. So, without further ado, let's go to the topic. This is not a product, this is a proposal for a new standard, and you are actively invited to give me feedback or to give us feedback. And we call it the SBOB, which is like S-bomb for runtime. So I brought with me a container. Yeah, and I'm going to read you the container bill of materials just for introductions. So this container contains 1 milligram of dimetindene maleate, purified water, and a whole load of chemistry. I'm sure that some people that might be allergic to some of these ingredients, they would find that very important, and also for compliance reasons, of course, the ordering of those ingredients is very important. But now, if you wanted to know if this container is for children or for adults, or for Alzheimer's patients, or for contraception, what do you usually do? You will read that indexcell, so in Danish. So, and now the question is, that I'm posing at the moment to the community, is why don't we have that thing in software for containers, where we say that if the pharmaceutical company that got that thing onto the market took, let's say, 10 years to test their product on humans, on I don't know what else, and distilled all of their knowledge into a little leaflet so that I can relatively quickly, as a non-expert, understand what that thing's supposed to do, and then there still are doctors that can override it, because still everybody is different. Still there are allergies and intolerances, so I can still react to it, right? And now the question would be, like, why don't we, when we are software vendors or CNCF maintainers, take our test runs, our test suites, and record the behavior during all that extensive QA testing and put it into a readable file that we then transfer to our users. And that's what this talk is about. So, but let's start at the beginning. So, in general, when you want to detect tampering with your runtime, what you typically need to do is you get data out. Some form of data, call it telemetry, call it observability, whatever you want, and then you need to figure out, was it bad or was it not bad? And for that, do you typically use rules? Now, if you are an SRE platform team, etc., or DevSecOps person, you need to write rules. And currently, it is on the teams to write those rules or to record profiles. Now, how about we turn this around? And we let actually the people that understand what's actually in the software write a good, secure, by default rule. And with each update of the software, when they know what new features they put in or they put out, how they reconfigure the network, how they change their mount propagations, they will also update the rules that come by default with the software. So far was the idea. And the big question that we had, because this idea was literally over coffee in KubeCon London, within sort of 5 minutes, it's like, yeah, why don't we do this? This is kind of obvious. And then the big question was like, yeah, but does it transfer? So if I do this as a vendor, let's say I have a Talos cluster, a fleet, on a kernel 6.4, and then I ship it to somebody who's running OpenShift on a kernel 4.4. Is that still going to work? Is it going to hold? And that was the thing that we had to actually check and find a method in how to generalize these profiles such that, and introduce templating, such that I can override and I can fit it into our entire ecosystem as we know it with as minimal friction as possible. And this was actually the idea so far was from me, but the name actually came from Vadim Bauer, the lead maintainer of Harbor, to call it the software bill of behavior, because it kind of fits. It's just like the SBOMs, but it's for the runtime parts, and it's for the vendor to attach to the software at the factory when they ship it. So we're going to use this, or we're trying to use exactly the same tooling stack that we've got for the SBOMs, just call them, instead of the M, with a B. Also here you see the SPDX spec. In this case, this is from Matthias from Armusec, the Kubescape CNCF project that can now, as of next week, officially support SBOBs, where it creates a flat file traced out by eBPF. It has segments for network, for capabilities, for the image hash, for file opens, for executables, and for syscalls, which is, well, if you are knowledgeable in these parts, you can basically edit it by hand, or otherwise you hope that the vendor provided you something correct. And again, what we're going to look at is what sort of knowledge are we distilling into, again, this leaflet, or this flat file, this flat YAML here. And if who here has ever worked with an LSM, a Linux security module, like AppArmor, SELinux? That is, I'm going to say, like 20% of people. So the UX is usually stellar, right? It's absolutely obvious how to do that. Yeah, exactly. So this is also another goal here, is to maybe we can generalize, we can significantly improve the UX on those tools now that we have eBPF and it works. Now, so this would be the incentive for the vendor, but what does the user get out of it? So if you had your container with your SBOB, you install it, and in case of Kubescape, you have now this profile, and it runs with the installer, and every time something happens that wasn't in that profile, you get an alert. Now that's called anomaly detection, which is considered a relatively advanced security feature that very few people can do in production. And that would come out relatively for free in this constellation, which is massively useful for the user. If you think about CRA regulation, NIS2 regulation, where you have a DORA regulation, where you have reporting of incidents within 4 hours, within 24 hours, how are small, medium enterprises supposed to cope with that? That was actually my main motivation for the user side, why I would love vendors to support this. For time reasons, I'm going to skip this one. Feel free to ask. One question I always get, is this alerting or enforcing? We're going to focusing only on alerting at the moment, but there are options to use the old enforcing ways that we've always used, because it's still the same content in the end of the day. So now, what is it we can actually, in this case, so a vendor would, so a pharmaceutical vendor would test for allergies and tolerances, the efficacy of the medicine. So what can we do as software vendors? What can we put into such a bill of behavior? Now, the first thing is that we run the benign behavior, meaning what we functionally expect our users with certain amounts of creativity or fuzzing to do with the software, so that we trigger network connections, and we trigger the syscalls, the file opens, and so on. And this gives the user on the other side a validation that the alerting and even the incident response would work, right? And we could also simply verify and install. There was this NPM debug package corruption, September 8th, maybe some of you heard it. And in this case, what we can say, if I install that, and instead of that thing looking like a debug package, it looks like a crypto miner. It'll have a totally different fingerprint. And at installation time, I can basically see, oh, there's something else in there. And if we had this in place, and we had NPM modules running, and maybe they were just pulling, as they often do, we could have seen where did we download the malicious payload and where did we not get it. Now, but we can even do more. We can also do negative tests, right? So as a CNCF project, I often get audited, like I have to come up with a threat model. I know, as a maintainer or a vendor, what are the crown jewels and how do I get there? And maybe sometimes I don't want to admit that necessarily, that something's not as greatly implemented as possible yet, but I can still distill that in a threat model and say, well, how would I, for example, in this case of Harbor, how would I compromise, how would I poison the registry? What options are there, especially in the inner workings? This shouldn't be the user guessing it, but what if we can also provide negative tests? So, for example, let's say, one of the critical exploits would be the malicious attack injection. So if you have a supply chain backdoor inside Harbor itself, like if they model it, the people that implemented it, and give us the test so that I can even check, okay, this is what the attacker did, would I see it? So I can basically check, am I blind to this attack? That means I need to do something else, or I'm not. And now with this comes also an incentivization for the vendor side to do this, is that this is a value add. This is something that I can monetize on and say, well, if I give you all these security tests for free, you don't have to write them. Well, that is a value, however you pay for it. And because whenever we introduce a standard, we obviously have to make sure that there is a value chain. Somewhat money, we need to keep the lights on. And this would be the big thing for the vendor side, why I can establish the trust and I can essentially sell tests for anomaly detection and for blind spot detection in my incident response to my client who is running critical infrastructure. Yeah. Now, the last question is, like, how would you ship that? Now, originally we thought it would come with the OCI artifact directly with the container. Now, that turns out to be wrong. It has to come with the Helm chart or equivalent, because all the config between the elements matters, and how exactly you boot it, how you run it, how you do mount propagations, again, how you install it, that runtime classes you'll be using, exposing it with TLS without, that totally matters. So it would come with the chart or whatever you like, customized thingies, equivalent things. Yeah, and so on the roadmap now, coming to the end. So currently I've implemented so the software consists of about 250 lines of bash, vibe coded by myself. No, literally, the cool thing is what we're condensing here is essentially the knowledge of the maintainers, and then we have to generalize it to get it across systems. Because that's the last question I haven't talked about, is that what if I run it on Kubernetes and somebody else uses K3S or RKE2? And so basically you start with working with the maintainer, setting up once, then you automate it. And this is something that I have gotten a lot of people helping me, vendors helping me, universities giving me hardware for, is like I emulate a fleet of different setups. And I run it across them, and then I superset it. And my mic is falling off. Let's see. Once I superset it, it can be hundreds of thousands of lines of code or lines of these entries. Now this is still cool for supply chain, because I can still validate exactly the installer is doing what I want on all systems. But if I were to run diffs, real-time alerting at runtime of a couple 100,000 lines, I have a memory issue. And this is where, for runtime, we need to generalize this. And this is why we're starting to support globs, so the normal, stars and so on, such that we can generalize, especially the pieces that we don't think are particularly relevant, because again, as the vendor, we have the threat model. So, and then we convert it back to Helm, and we can test, again, over the whole matrix, what amount of blindness, what about of alert, false negatives, false positives we're now getting. And we can ship that, again, in our container insert. So the summary is, we would go if we get vendors to adopt this, we can go from descriptive, meaning we're recording our own behavior, sometimes with malicious stuff inside. We go to people giving us the prescribed desired deployment, and thus creating the first time maybe real scale in security here. And hopefully enabling users to do this breach alerting with incident alerting within the time that is required by the law. I know, you're kicking me out, so if you want to try it out, I made a lab, it's an online lab, it's free for 1 hour. You can try it out yourself, because I know this sounded like magic, or maybe, did it sound like magic? Raise your hand if it sounded like magic, or it sounded, okay, who says it was obvious? Okay, couple people. Okay, so anyway, bugs included. There's a live lab. We're very, very actively developing it. Give us feedback, anything. And with that, I leave you for the summary. Software bill of material, please, community. Yeah, let's make it happen. I think there's a lot of value in it. And thank you so much.